Welcome to Analyst Talk with Jason Elder. It's like coffee with an analyst, or it could be whiskey with an analyst reading a spreadsheet, linking crime events, identifying a series, and getting the latest scoop on association news and training. So please don't beat that analyst and join us as we define the law enforcement analysis profession one episode at a time.
How we doing, analysts? Jason Elder here with another LEA podcast deep dive. We're welcoming back to the show Andreas Olligschlaeger. Ollie, how we doing?
Doing great.
All right, so just a short turnaround here, but I had you on the show about a month ago. You said something that really sparked my interest, so I wanted to bring you back to do a deep dive episode on AI, because one of the things that you said during your episode was that media and AI is really overblown. And so we want to bring you on here and talk about your perspective in terms of AI, what it is not, and maybe calm some fears of some analysts who think that their job's about to get replaced.
Mm-hmm.
So,
Sure.
So for the listeners, we're going to go through the history of AI, where in law enforcement, where it can help analysts, where it may not help analysts, and really get into some useful tools that analysts can use. And then we're going to finish up with an ethics talk there at the end. So, all right, Ollie, now the floor is yours.
Okay. So let's first talk about the history of AI in law enforcement, right? So at its fundamental base, AI is about pattern recognition. Well, that's something that crime analysts have been doing for decades, right? I mean, crime analysis is all about pattern recognition. And there are many non-quote AI related techniques that analysts have been using forever, right? For example, regression analysis, things like that, spatial pattern analysis, all those kinds of things, right? But specifically, as it relates to what we know as AI today, there's actually a bit of history in law enforcement. It's still not very pervasive today, but let's see. So in the early 90s, autonomous neural networks were the first applications to be used in law enforcement, and they were used for predictive policing. My dissertation started that, but then they were also used for video OCR, and that gave birth to license plate readers, for example. And it was also used in natural language processing. So that was the early 90s. Then in the early 2000s to 2010, we started getting into deep learning convolutional neural networks. And this was possible not necessarily because the algorithms had changed or anything like that. It was because the computing power was getting much, much more powerful. And actually, it's computing power, not so much necessarily algorithm development, that has driven the burst in AI over the last 20 years or so. So in the early 2000s, we saw things emerge like facial recognition, object recognition, background detection, gait recognition, and video analysis in general, and also things like classifiers and other methods of predicting things, right, including crime. Now, currently, the focus in law enforcement, where it is being used, is anomaly detection, graph neural networks, graph RAG, which stands for retrieval augmented generation, and community detection, as well as large language models. Now, in today's world, large language models is what everyone thinks of as AI, right? But it's only really one tiny aspect of AI. So in the last episode, when I said we're living in a bubble, the bubble is LLMs. It's not the rest of AI. There are a huge host of applications for AI and machine learning in law enforcement that do not involve LLMs necessarily. However, LLMs do have a use already today if they are implemented correctly. So let's take a little bit of a deeper dive into that. So where could LLMs be used in law enforcement today? Well, the most obvious use case is in writing police reports, right? There's several companies already starting to do this, and there's definitely some pros to it. It saves time, it improves report quality. I'm sure every crime analyst has seen an arrest report or an incident report and laughed out loud at some of the grammar and spelling and things like that, right? I know I did when I was a crime analyst. And definitely there's room for improvement there. However, the cons are that LLMs can be biased and get things wrong. And they get things wrong all the time. Everybody's seen countless examples of how Grok gets things wrong constantly, things like that. So that's one con. Another big con is, especially if you're working in a classified environment, is depending on where the large language model is housed, if it's like on an external server, classified or sensitive information may be inadvertently uploaded to servers outside of an agency, which can be a huge problem, right? Things like chain of custody for evidence, right? What do you mean you uploaded it to Grok or ChatGPT or whatever? You can't do that, right? So there are ways around this. There are versions of, for example, ChatGPT that can be hosted locally at an agency. It's not necessarily cheap, but it's definitely doable and has been done. I've seen it done. So that's one way around that issue. But LLMs today, for use by a pre-trained model, are still not quite there yet, in my opinion. And that is because they release a new model every 6 months to a year. Well, you never have the latest data, the latest things that have happened, right, in the past 6 months that are actually in the language model. And then so, for example, if you have something in your own agency that you would like to incorporate into that language model, you're out of luck, right? You can only use whatever that model was trained on. So that's one potential use case, right? Writing police reports. Then another potential use case, and this is good for crime analysts, is helping an analyst write code. So most crime analysts know some programming, right? They maybe all likelihood they know Python. Some of them might know Java, right? So that's great. But if they want to write their own machine learning models or develop their own machine learning models using their data and not necessarily using LLM, say they want to do something like anomaly detection, right? Where you have like complex data and you want to find data points that are anonymous, that stick out, right? Which is most often a nonlinear problem. You can't use regression, for example. Even logistic regression won't work well on those kinds of problems. And not every crime analyst obviously is an expert programmer. So most programming environments like Databricks in Azure, for example, have an AI assistant that helps you write code. So I have used it at work, and it's currently wrong about 80% of the time. And it takes more work to undo what the AI assistant coded for you than it would have taken just to write the whole dang thing yourself in the first place. However, I've been using it for about 2 years, and I am definitely seeing a gradual improvement. And I think in about 3 to 5 years, it's probably going to get to the point where you can ask the coding assistant what you want a program to do, and it will probably mostly accurately write 90% of the code for you, if not 100%, and then all you have to do is tweak some parameters and test it and things like that. So as you were saying earlier, crime analysts have more and more things to do every year, more tasks and things like that. This is one area where AI can actually help a crime analyst. It's not going to put them out of a job, right? Because somebody has to still drive the AI. But something that a relatively newbie in crime analysis would have to read a book, take a couple of classes in Python and things like that, it might enable them to do something in a week that would otherwise have taken them a month to do. And so that's a positive thing. And from my own experience learning programming languages, if somebody gives you an example of how to do things, that helps learning. So if the AI provides an example on how to code a certain problem, then you learn just by watching the AI do it. So it's also then becomes a learning process, so that next time you can just either do it yourself or to be more specific in asking the AI to do something when you're asking it to solve a problem for you. So that's a huge area of promise, I think.
Yeah. Well, I'm glad you said that about Databricks, because I get frustrated with Databricks, and when there's something wrong with my code, it does the AI to try to fix it, and I'm like,
Right.
That I
Yep.
just read through this whole thing, and that's not that
It's
didn't
not
help me at
right.
all. So
Exactly. Yep. That's we've all been frustrated by it, but
yeah.
now your average crime analyst probably won't use Databricks, but because it's mostly cloud based, but they might use ChatGPT, for example, to help them write code.
Mhm.
Now, I've tested ChatGPT, both Python and C, to see what it comes up with when I give it something to work with. So one example of something that I did, we have data in a graph database at work, right? And has people, places, organizations, addresses, things like that, typical graph database. And we also use I2 Analyst Notebook. And I wanted to figure out a way how to convert a subgraph in a graph database into an I2 link chart. So I asked ChatGPT to do it, and it absolutely failed miserably. It's like laugh out loud miserably. The code on its face looked okay, it might work, right? But then it imported a bunch of packages which turned out to be non-existent, right?
Mhm.
And so it's definitely not there yet, but it will be there at some point. I'm
Yeah.
very confident that that's
Yeah.
going to happen.
So
Yeah.
just so real quick though for our listeners, when you just quickly explain subgraph and graph.
Okay. So I was going to get into that in just a little bit, but
Oh,
let's yeah,
okay.
let's
Sorry, I
let's no,
jumped
but
ahead.
no worries. Yeah, let's get into what is a graph database. Think of the Kevin Bacon game, right? Everybody's heard of that, right? Somebody that knows somebody that knows somebody that knows somebody that knows Kevin Bacon, right?
Yeah.
And usually it's at most 6 degrees of separation. So you've got those in a graph database, those are called hops, right? So, for example, in a crime-based graph database, you might have a suspect that is linked to a phone number that's linked to an address,
Hmm.
which is linked to an incident report. And one of the other subjects in the incident report turned out to be the victim of the suspect, right? So you traverse a graph database from one node, which is an entity, phone number, address, person, what have you, and you try to find connections between data. And graph databases make this incredibly easy compared to, say, your traditional relational database. You can do in graph databases in milliseconds what would take a SQL query connecting multiple data sources hours to run, right? And the other advantage of a graph database is now that you have your data in a graph database, you can apply all kinds of techniques to create communities. You can you can generate something called Leiden communities that connects all individuals, subjects that have properties that are similar together into what's known as a subgraph. So let's say you've got a graph with 1 billion nodes in it, right? And that sounds like a lot, but it's not really. I've worked with graph databases that have 10 billion nodes and 20 billion relationships in them. So you do this community detection and you get a subgraph. And this subgraph is, say, a network, maybe a criminal organization, organized crime group, what have you, or people engaging in suspected fraud based on certain parameters, right, that are present in the graph. And then that's what we wanted to export to I2 once we've identified, a network within the graph. So a subgraph is basically a fully connected portion of the entire graph database itself. So did that make that clear to you?
Yes. Yes.
Awesome.
Thank you.
Sure. So let's see what we can do next with large language models. Well, let's first talk about something else you can do with a graph database where my colleagues and I have been incredibly successful. So one of the problems law enforcement has is that it takes months to years sometimes to manually sift through data to identify an organized crime group and generate a lead that will lead ultimately to an indictment. And I've spent most of my career trying to turn those figures around, right? From where crime analysts and investigators spend 80% of the time, 90% of the time sifting through data, and then maybe 10% to 20% of their time working on actual cases. So graph databases are fantastic at reversing those numbers. So to give an example of a project I worked on, we had a very, very large graph database with billions of nodes and billions of relationships containing certain information about a certain type of crime. And the goal was to automatically, using AI, generate leads that were not false positives. And that's another important thing, right? When you're a scientist working in law enforcement, you have basically one shot at convincing an investigator that what you're doing helps them. Because if you give them that one wild goose chase, they're going to say, this is a bunch of crap. I'm not going to use it anymore,
Yeah.
right?
Yes.
So you have to be very, very careful. So what we did, we put all the data into a graph database, and we had a number of individuals, about 15, 20,000 individuals in the graph database that we knew that had been under investigation for a specific type of crime. And so the first thing we did was we built a classifier. So we used that as training data, used traditional machine learning techniques that allowed us to classify every individual in that graph database, whether that person was likely to engage in that type of crime or not engage in that type of crime, right? So that was the first step. Then next, we ran community detection techniques, which is a type of graph AI. There's several types. There's Levine community detection, there's Levine community detection. Each has their pros and cons, like any other technique, to identify communities of like individuals that were likely to have committed or participated in that particular crime. And then what we found was that there were a whole bunch of individuals in these communities that were known criminals, had been prosecuted or investigated for that particular crime, connected to other individuals that investigators were completely unaware of, and incidents that they were completely unaware of, right? So we basically added people to existing known communities of offenders, but then also found other communities that were classified as potentially engaging that type of crime that were previously unknown to law enforcement. Mm-hmm. So then we took all these communities of interest, and each community got a particular score and rank. And then we ran anomaly detection on those communities. So we ranked the communities with respect to how anomalous they were with respect to other communities that did not involve individuals likely to have engaged in this particular type of crime. So then we were able to rank and score each community by a unique score, right? So the next thing we did is we vetted each one of those leads. A whole bunch of subject matter experts looked at them, investigators looked at them, we looked at them, and that brings me to a very important point, right? Just because AI says this is a lead does not necessarily mean it's a lead.
Yeah, validation.
Yep, it always has to be a human in the loop, right? Because we don't want like Big Brother determining whether somebody's guilty is guilty or not, right? Obviously. What we found was that the leads that we generated were amazingly accurate. Probably, I must have vetted like 200-300 leads myself. My colleagues and I have vetted thousands of them, and almost every single one of them was a viable lead. In other words, we found other corroborating information that, yes, this person, this was definitely a valid lead. There was other information out there to support that this was a lead. Mm-hmm. And the beauty of this, we generated thousands and thousands of leads. Once the algorithms developed, it took 2 hours. 2 hours. It would have taken an army of investigators, entire careers, to have generated that many leads that are viable. Yeah. So graph databases have an amazing potential in law enforcement. And as I said in the previous podcast, the good news is that the best ones are all open source. Neo4j, Puppy Graph, the interfaces, it's all out there. There's a ton of how-to guides, all of that stuff, that would help a crime analyst who's interested in learning how to use them to actually use them. And the nice thing too is if you're a crime analyst in a small to medium-sized police department, you're not looking at billions of nodes and records and relationships. You're looking at maybe tens of thousands or hundreds of thousands. And that's something that any desktop PC can handle. So, you do not need a giant computing infrastructure to do that. Now, if you're New York PD or a federal agency, different story, right? But your average crime analyst with the data that they have should have no problems integrating that into a graph database. So moving along and sticking with graph databases, let's go back to LLMs. So is there any way that we can use LLMs and combine them with a graph database, right? It sounds esoteric, but as it turns out, yes, we can, and people have done it. So there's something called GraphRag, which I talked about earlier, which means retrieval augmented generation. Traditional RAG is a technology that incorporates private records with a pre-trained LLM, retrains it so that your own personal data is incorporated into the model, and then you can ask questions about your data, and the LLM is smarter than it was because you trained it with your own data. It's vector-based, and it relies solely on semantic searches in vector databases, right? So basically what that means is all the documentation you feed it, it breaks it down into text snippets, stores those in what's known as a feature vector. And then once you incorporate your own data with that, your own data snippets, right, they're incorporated into those vectors or set of vectors. And it then ranks the set of those text snippets based on a natural language query and outputs the results. So that approach is better than just using an LLM, like an old standalone pre-trained LLM. But one of the drawbacks is it lacks context as to how those snippets are connected. Well, how do we know that this feature vector is connected to that feature vector, right? So it's not really well suited to answering more than just very basic questions about your own data. And especially it can't answer questions that require multiple hops, right? Okay, so you're asking a question, say, about an incident and maybe a suspect involved with that incident. And then you can't answer the question of, well, a follow-up question, for example, might be, how is that suspect connected to other entities, addresses, places, incidents, things like that? So that's one problem. And the other big problem with it is that basic RAG can't explain why certain snippets were retrieved. So there's a lack of explainability. As any crime analyst would know, that if you tell your supervisor, well, here's the result of my research, one of the first questions you might get is, well, can you explain to me how you arrived there? Just simply saying, well, I queried an LLM, that's not good enough, right? And it wouldn't be good enough in court either.
The computer told me so.
Exactly. And this is where GraphRag comes in, right? So GraphRag is a generative AI technique that leverages LLMs like basic RAG, but the difference is it creates a knowledge graph, right? So just like the 6 degrees of separation, suspects, addresses, phone numbers, email addresses, and so on and so forth, each node represents a snippet of knowledge, right? So basically what you do is you feed it a whole bunch of documents, incident reports, arrest reports, CAD reports, whatever you have, and it automatically extracts entities, people, places, names from it. That's one. But it also extracts the context, the textual context of how these entities are related. So now you have that in a graph. So what you do then is you run community detection algorithms on them, just like anything else, and it generates communities of like pieces of information, whether that's text, whether that's people, places, so on and so forth. And then it also creates like community statistics, right? So each community of like pieces of knowledge have certain metadata characteristics, like number of people, number of phone numbers, for example, geographic location, all those kinds of things, right, are embedded into those community statistics. So then what happens is this all aids context to LLM queries, right? And allows crime analysts to automatically identify associates, organized crime groups, and crime trends in originally disassociated documents. So adding these agency documents then helps augment pre-trained large language models with private data sets and helps connect the dots in ways that traditional graph database models cannot, because traditional graph database models just connect entities, right? But by adding this LLM-based text snippets to the graph as another type of node, now you have context. And then you can use just a regular query interface like ChatGPT to query a graph database And it outputs not only what it finds, but how it found what it found, how the pieces of information are connected. So now you have explainability.
You can
And
trace the steps.
you can trace the steps, you can identify the community. So now you can go to that community that you've just now identified and download that into an I2 link chart, right? You'd have to write some code to do it, but it's definitely doable. I've done it. It doesn't really take that long. It's like maybe a couple hundred lines of code, right? So it's very doable. So now you have an LLM that I earlier said, yeah, it's an AI bubble, ain't quite there yet. It's just pre-trained models, the old data. Now you have it incorporated with your own data in a graph database that allows you to establish context and generate much, much more useful queries and especially more useful results that are really pertinent to what it is that you're looking for. And you can explain them. And then the other great thing about it is I said that one of the problems with LLMs is that they're only retrained every 6 months to a year or so. So you got like a model release. GraphRag system, you can update on a regular basis. Every day, as new information comes in, you can automate the process of importing everything, rerunning the algorithm. It literally takes an hour, if that, half hour, depending on the size of data you have. And that's it. You'll have a constantly trained, up-to-date model that will provide you with up-to-date results. So as new data comes in, you might be adding a person or a document to a community, and so you ask the same query, say on a Monday, and then at the end of the week, you ask the same query again, and you get additional results, which would never happen with just using a simple LLM.
If I'm an analyst listening to this,
Mm-hmm.
and you already kind of mentioned it, I'm always amazed with what analysts are asked to do at a police department, all
Right.
the different hats that they wear. And if I'm listening to this, I mean, these are two pretty big entities, right, between the LLM and the graph database. And so
They are
just
and they aren't.
just trying to get my head around it to say
Mm-hmm.
like, okay, like how would I even implement it? How would I get started? How to add this to my already pretty full plate?
Right. So again, as I said earlier, the good news is that first of all, this software is all open source. There are plenty of how-to guides in how to do this. Neo4j, for example, has an entire section on GraphRag and how to implement it with examples. Everything is there. You just have to do it yourself. Would this really help crime analysts, a sole crime analyst in a small police department? Probably not. But in a medium-sized to large police department that has multiple analysts and some analysts that are, have quite a bit of programming background and expertise and database expertise,
Mhm.
it shouldn't be a problem to do this. You can stand up a graph database in less than a day, depending on what kind of access you have to your RMS system and CAD system. You can automate the intake process. Again, there's a lot of GitHub repos out there that show you how to do this. You just adapt them, things like that. So just to set up a graph database, just using, say, metadata from incident reports and arrest reports and things like that, and CAD data, might take a couple of weeks to a month, one to two people. And then you have your data in there, and then, you just basically write code that periodically updates the graph as new data is input into the RMS or the CAD system. It's really not that complicated. And LLMs are out there. There are ones that are downloadable locally to your machine. There's slimmed down version. There's a what's it called again? ChatGPT for all, I think it's called. It's a downloadable LLM that has an interface that you can connect to things. That no data is sent outside the agency, so it takes care of that issue.
Yeah, that's what I was just
Um,
going to ask.
yeah, it's not as powerful as ChatGPT, the commercial version of it, obviously, but
Hmm.
again, augmenting it with your own data makes it much more powerful. So there are definitely ways to do this, and it doesn't require a whole bunch of expertise. All the tools are out there, all the guides on how to do this are out there, and they're free.
Hmm. Yeah, and I definitely see the benefits of it because I mean one of the things that I remember being in Baltimore Police Department, and we had 3 analysts. There was 9 districts, and we basically divided it up, the burglary, robberies, and thefts by district, right? And I was trying to keep up, trying to read as much as I can just with my 3 districts, let alone what was going on with the other analysts this district that were just nearby, right? And
Right.
it's like I just couldn't keep up. There's no way I could read everything and know everything to be able to connect some of all these dots. Because once you get to so much data, there's a maximum comprehension there, right?
Exactly.
It's not like, I've talked to analysts that are from small police departments. They're like, yeah, I read every crime report yesterday that happened, that was reported yesterday. I mean, well, I mean, it doesn't get, the police department, the city doesn't get very big before you get to something where it would be impossible to read every police report from a city.
Exactly right. And that's just the thing. A crime analyst, they can't remember what they read 6 months ago, unless it was some major incident like a homicide maybe in a small town. But a graph database remembers all that stuff, and it's in there. So it can discover things and relationships that even a crime analyst who reads every police report wouldn't know exists. Right? And that's the beauty of a graph database. That it'll tell investigators things they didn't know. Like one of the first critiques I got when I started crime analysis was an investigator tell me, or a detective, well, tell me something I don't already know, right? And that is what graph databases truly excel at.
Yeah, and that's because you get sometimes the analysts will get the opposite, like, oh, well, you gave me something that I already knew. Like, I wrote most of those reports. Of course, I know that there's a problem in that area.
Yeah,
right?
exactly. Right. I think graph databases right now are where GIS was in the mid to late 90s. Right? Some police departments were beginning to use them. They saw the benefits. This started after the Drug Market Analysis Program, which was an NIJ project that began in the late 80s. And that really showed the benefits of crime mapping. And that led to the Crime Mapping Research Center that existed for about 6 years, maybe 7. Nancy Levine was involved with that. And that really put crime mapping on the front burner, right? To the point where now everybody does crime mapping. Every crime analyst knows how to use GIS. Graph databases 10 years from now are going to be the same because they're so powerful. And especially as RMSs and CAD systems are collecting more and more data, and as more and more of that data is in free-form text format, we can use graph databases combined with RAG techniques to process, collate, and analyze all that data on an automated basis.
Yeah. We need to get you at conferences talking about this stuff, because I think you even mentioned it in your first episode that this is a lot of open source. It's there for the taking.
Yep.
But there'll be vendors out there charging you an arm and a leg to have their version.
Exactly. And I mean, some vendors have great stuff, right? But there are vendors that promise the stars and the moon, and it turns out to be all unicorns and rainbows, right? At a huge cost. Now, there are some good vendors out there, don't get me wrong, right? But the problem is that a lot of the decision makers in state, local, municipal agencies don't have the technical background to be able to even evaluate if a vendor is selling them a viable product that's worth the money.
Yeah.
And that's a problem that dates back to the 80s.
Yeah.
When people were looking at RMSs and CAD systems.
So it sounds like for the analyst, the good news is that, at least for the time being, the AI is not going to just totally replace the analyst.
No.
But it also means is, in order to keep up, there's a lot of extra work.
There is.
Right.
I would encourage every crime analyst to take as deep a dive they can into AI. And you can start with baby steps, right? There's lots of tutorials out there. Play around with some data. My suggestion would be start with things like anomaly detection, random forest classifiers, or isolation forest for anomaly detection. Graph databases, very easy to set up. Lots of tutorials again. Just spend couple of hours a week reading up on it first, things like that, and then maybe downloading Neo4j or downloading Python if you haven't already, and the packages, and start experimenting, because it's coming. AI in crime analysis is coming, and it's coming in law enforcement as well. In general, the feds are already heavily looking at using AI, and a lot of state agencies are as well. It's only a matter of time before it trickles down to where even the smallest police department will use AI in one form or another, just like crime mapping trickled down into smaller police departments over time.
Yeah,
For sure. I mean, and again, graph databases are only one part of AI, right? There are many, many other techniques, but we'd be sitting here for 10 hours if we went through all the various uses of AI potentially in law enforcement.
yeah. Well, hey, we can always bring you back for another deep dive. That's
Sure.
definitely a future episode. I do wonder with analysts what their relationship is to the police department's IT staff.
You're right.
That's what I
Yes.
always think of is this, because I mean, when I was at Baltimore, man, they had such few IT staff. Like it was basically 6 months before if you put a request in today, it was like 6 months, before
Yes.
anything was even done. I mean, analysts did not have dedicated IT staff assigned to them. And so, and I'm hoping, of course, different departments, different times, but I do hope that analysts have such a relationship with their IT that there is this potential for a great partnership to
Absolutely.
bloom
Yeah.
and to
Absolutely.
develop this. As you said, it's coming.
It's coming, and key departments are going to have no choice, right, but to do this, because if AI gets to the point where there are, say, a dozen or so agencies around the country that are actively using AI, having a lot of success with it, that's going to put enormous pressure on other agencies to also use AI, and in turn, it'll put pressure on the IT department. So, and as a lot of police department, as a mitigating factor here, as a lot of police departments move into the cloud, right? And for now, that's just the larger police departments. In the cloud, everything's available on demand. I mean, an IT person, say in New York City, for example, assuming they're in the cloud, I'm not sure, but I'm pretty sure they are, could spin up a Neo4j database in like 30 seconds.
Yeah.
Right? So, and boom, it's there. It's not like where somebody has to download everything on your computer or configure it for you and do all that kind of stuff. I mean, that's where cloud computing is a sea change difference from where we were 20 years ago or 30 years ago. However, the caveat is it comes at a price. It's not cheap. But for smaller to medium-sized agencies, there are alternative solutions because it's all open source. You can download it all for free and experiment on your work issued laptop or workstation or whatever that you use at work. So there is no technical barrier to doing it other than, yes, the IT department might take 6 months to install it, but that hasn't changed since I started working in law enforcement. But yeah.
Yeah, and I was just thinking, we were talking before the call, is like we're getting up there in age, and we're getting to the point now where we're gonna have to be old dogs learning new tricks, and not necessarily just sticking with what we know.
That's right, and yeah, I don't care how young, how old you are as a crime analyst or any kind of law enforcement related analyst, whether it's intelligence, crime, whatever, you're never going to stop learning, and it's only going to get worse, right? You're going to be constantly learning new things. Like my current job, I've been there 3 years now. I learn something new every month.
Yeah.
There's a new technique, a new type of database, all kinds of things, and yeah, you're never going to stop learning. But by the same token, that also makes you extremely valuable, right? The more you learn, the more valuable you become to an agency. And so if you are determined at learning AI and you're in a small to medium-sized police agency, you would easily be able to find a job in a larger police agency or even as a contractor. So it's a win-win situation. The more time and effort you invest in learning this kind of technology, the better off you're going to be, and for you, it's going to be great for your career too.
Yeah, nice. Did we get to the ethics portion, or is that
Not
where
yet.
we're going next?
That's where we're going next. So
Okay. Well,
with
that's
all
yeah.
with all these wonderful machine learning techniques, right? There are some big caveats. And one is that whatever technique you use in AI, whether it's an LLM, whether it's other types of machine learning like anomaly detection or what have you, and I kind of hinted at it before, is that you have to be transparent about it, how you
Mm-hmm.
did it, and you have to be able to explain what you did and why the AI arrived at the conclusion that it did. Because at some point, there is going to be a point where leads generated by AI are going to wind up in court. And so everything goes through discovery, and defense lawyers are going to ask, well, okay, how did you arrive at the conclusion that my client was a suspect of a certain type of crime? And you can't just say, well, the AI predicted it.
Yeah.
So you have to be able to explain, back it up with code, step by step, how you did this, that somebody else could potentially replicate it, right? No different from writing an academic paper or writing a dissertation, providing all the data, the code, algorithms, everything, so that another researcher can replicate what you did and replicate your findings, right? So it's going to be very, very important. I mean, the whole black box thing was a huge gripe, for example, with predictive policing. There were, I don't know if you remember back in the 2000s when predictive policing first took off, people were complaining, well, it's targeting minority neighborhoods. You know, can you
Mm-hmm.
explain why it's doing that? Nobody could. And a part of that was because, well, the vendors were the agencies that use vendors for their predictive policing and not in-house. The vendors were, of course, reluctant to release their code and say, hey, yeah, this is how it works. So
Mm-hmm.
again, this is another reason why an agency, in theory, is much better off doing this kind of stuff in-house with expert personnel than spending millions of dollars and hiring a vendor to do this, right? Because
Yeah.
everything they do is proprietary, and as soon as you do that, you have less transparency, you've got less explainability. And then the other thing is that there has to be a human in the loop, right? Always, 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 right? The more sets of eyeballs on something produced by AI, whether it's the leads or an analysis or things like that, everything has to be vetted by human beings to make sure that this is not a false positive, because there's an ethical obligation of anybody working in law enforcement to make sure that innocent people aren't charged, right? And have to go through the process of hiring a lawyer and things like that, even though they're innocent, right? So it's extremely important. But in developing all of this technology in the first place, and this is not just true for AI, it's true for technology and law enforcement in general, it's really, really critical for investigators, prosecutors to be involved in the development process, right? So they have buy-in, they trust the technology, they understand the technology, and can provide feedback to those implementing the technology based on inaccuracies and things like that, how it helps them, and it just provides a closed loop system with a constant continuous feedback loop, right? Unfortunately, in the past, a lot of law enforcement technology has been developed in a vacuum, right? Somebody sees a problem, they go out, develop a solution, they market it, and no investigator was involved in the making of the product. And so, and there's no feedback, right? And we definitely want to avoid those types of things moving forward.
Yeah, I think it. I mean, I think this also goes back with corroboration and
Hmm.
validation
Yep.
and whatnot. And because it shouldn't be to the point where you're testifying in a vacuum. Like this is
Exactly.
we base our decision, every decision, solely on what came on that screen.
Right.
Like it's
Right.
leads, it's okay, this is pointing you in the right direction, and then you're using other sources of information or what they deemed good old-fashioned police work
Yes.
to then corroborate what the LLM suggested.
Exactly right. Or not just LLMs, any AI technique, right?
Hmm.
Or any technology for that matter. It's yeah, it's absolutely crucial. And It's the last thing we want is for data scientists and researchers to be seen as these pointy-headed kids from academia or wherever trying to tell law enforcement what to do and how to do their work, right? You want people to work together as a group, right? Everybody has their certain expertise. I've always said, in my experience, when I first started working in this field, over 30 years ago now, was you put an academic, a cop, and an IT guy in a room, and they all speak a different language. They all speak past each other, right? And as a result of that, in the early days of technology development, law enforcement, very little actually got done because the cops mistrusted the academics. They were all pointy-headed guys from university who had no clue about practical law enforcement. The IT guy was just trying to figure out what the hell do they want me to do, and develop. And so it's those days have improved, obviously, but they're still not where they should be. Which is why I keep hammering. Everybody has to work together. And the more they do, the better the outcome's going to be.
Yeah, very good. All right, Ollie, thank you again for all this information. I guess if somebody wants to get a hold of you or somebody has follow-up questions, what's the best way to contact you?
You can just send me an email or LinkedIn.
Okay. What is your email?
Olligschlaeger Andreas@gmail.com.
Okay, we'll definitely put that link in the show notes, and we will also put links to additional information on all the different programs and LLMs and graphs that were mentioned here today for more information. So definitely for the listeners, check out those show notes. All right, Ollie, I just give you the last word. It is the holiday season, so happy holidays, be safe, looking forward in the new year, but I'll give you the last word.
Last word is Happy New Year. And have a very safe and prosperous 2026.
Thank you for making it to the end of another episode of Analyst Talk with Jason Elder. You can show your support by sharing this and other episodes found on our website at www.leapodcasts.com. If you have a topic you would like us to cover or have a suggestion for our next guest, please send us an email at leapodcasts@gmail.com. Till next time, analysts, keep talking.